Tonight I wanted to shoot a video just to show a real simple job on how to use a chisel to knock rivets out of a wear strip on an aluminum snow pusher and to put new rivets in and replace that strip. And if you look at the snow pusher that needs to be have the metal edge replaced, you can see we've got a strip of steel that originally was about 1.25 inches wide, and if you look at the front now, you can't see any wear strip left showing on it. If we look at one that I just replaced, here's a strip that I replaced right at the end of last winter, and you can see that we've got about a 1/2 inch of wear strip showing, and it usually, depending on how much you have to push snow during a winter, it'll usually last 2 or 3 winters before that metal strip wears off and has to be replaced again. Step one, we need to support the snow shovel on a good solid surface, so we've got something to support it when we hammer on it with a cold chisel to break the rivets loose. And my workbench is made out of 3/8 thick solid steel, and so it's reasonably solid, and we can pound on it pretty hard without having the table move around on us. So we'll use the vice grip style C-clamp. Snug it down. Get that one tied. I think I can snug this one down a little bit more. Okay, now we're clamped. Okay, next we need to talk a little bit about safety and using a hard steel that we hit with a hammer. That's not always the safest thing we can do. One thing I wanted to show is just a little bit of caution on using a cold chisel. Here's a cold chisel that I just pulled out of my toolbox that I haven't resharpened yet. But if you look at the end and you see how it's all broke off in maybe 2 or 3 pieces, it just literally shattered like a piece of glass the last time I used it. And it should have a nice tip that looks like that one. Here's also a punch, and again you can see that the end just simply shattered. And that's somewhat the nature of using hard steel, because that chisel has got to be extremely hard or it's not useful. And every once in a while it gets just a little bit too hard, it gets too much shock loading, and it just simply shatters like a piece of glass. When it does that, those hard steel fragments can go nearly anywhere, and I've pulled a couple out of my hand over the years, and while that hurts a little bit, that's not a big deal. But on the other hand, pulling one of those out of an eyeball is a serious piece of business. And so, saying it's important to use safety glasses when you're striking metal tools with a hammer should go without saying, but it's an important statement to say. And absolutely, I've violated that rule and got by with it a few times. I've also made a trip to the eye doctor and had them sat there in the chair while they gouged around and pulled a piece of metal out of my eye. So wear safety glasses when you're using a hammer to strike hard tool steel. Well, now we're going to take our cold chisel, and a couple of details on which way you want to hit. If I struck the chisel this way, there is not hardly any mass of steel backing it up, and I don't get near the shock load or the impact on that rivet, versus if I turn and run my blow this way, then all of this steel that is in front of the tip of the chisel is, in essence, that mass has to flex a little bit or move to cushion the blow that I put on that rivet head. But because there's a fair amount of mass and that's a fairly thin rivet head, it should come off fairly easily. And so get into position. I'll pick out this one in the middle, and that rivet is done. Go down and do the next one. That one's gone. That one's gone. Well, I think that you've kind of got the idea on what a wood chisel will, or a cold chisel, not a wood chisel. We'd run a wood chisel in the first blow, but what a cold chisel will do. And actually, this cold chisel, as ugly as it is my very first attempt at forging something, or heating up a piece of steel red hot and beating on the end of it. And so you can probably recognize that as a piece of reinforcing bar for concrete. When I was in high school, I discovered that if you got a piece of steel hot, it would become soft. You could pound on it with a hammer and shape it, and you can see that I didn't have very much skill at that time, and I kind of got a fishtail looking shape that's pretty ugly. But the reality of it is that by dumb luck, because I knew zero about metallurgy at the time, I just knew if you got it red and dunked it in cold water, it would get hard. And it just so happens that most concrete rebar does have a fairly high carbon content to it, and so it actually takes hardening fairly well. It's relatively long. It's got the ribs that make it easy to hang on to, and so the reality of it is, for a chisel that I made in a few minutes when I was 16 or 17 years old, this one actually works pretty well, and I've used it a heck of a lot over the years. And you can see that the tip, we knocked off several rivets, and the edge is still real nice on it. Well, I've still got a couple of rivet heads left. I want to show just another methodology that works. And one of the keys that made this one look very easy to do with a cold chisel was the fact that I've got a very solid, heavy surface to pound against. And if you don't have a surface like that, without a solid table like that to back up the edge, it would not work nearly as well. But if you don't have a solid way to hold it, another method is you can take a hand grinder and just grind that rivet head off very quickly. And so, same thing here. And you can decide for yourself which one makes the most noise or the most mess. Using a grinder will take heads off fairly well. Personally, you know, comparing the two methods, cold chisel's got a lot going for it. pretty simple, low-tech methodology. Next, I wanted to bring in the camera and just look at what the close-up of where we knocked the head off. You can see the steel that's shiny, and then the rusty spots, the center of the rivet. You can see another one there, and you can see the one where we use the grinder to take their head of the rivet off, and the one out here on the end. Next, we want to use a punch to punch the what's left of the rivet out of the shovel head, and we'll use a punch like this. This is a pin punch. And so if you see, if you can read the size, it says that's a 3/16 pin punch, which means that the diameter is 3/16 of an inch, and it'll work on a 3/16 rivet. I've adjusted the clamping position so that there's space to knock the rivet head out, and so it's just simply line up the punch on the rivet head and knock it out. Line it up, knock it out. Knock it out. And that's all there is to knocking all those rivets out. One last detail that we need to do is we want to use this metal strip to be a guide for drilling holes in the new metal strip. And it would be close, but it wouldn't be exactly the same. Because the center from hole to hole may not be exact along the length of the snow pusher. And so I'm going to put an R just so that I can remember that's the right edge. I'm going to put an R on the shovel, and then that way when I line up and drill holes in the new piece of steel, then I can make sure that the right end of the new piece aligns with the right side of the shovel. Now I've clamped the old wear strip on top of the new piece of steel. All I need to do is take the center punch and just go down, line up in each hole. And now I've got each hole marked exactly where the old holes are, and all I need to do now is drill. If you have a drill press, that's by far the easiest way to drill a hole in a piece of steel, but this is not very thick, it's not a very large bit, and so all I need to do is clamp it in the vise, use a 3/16 bit since we've got 3/16 rivets. And we've got a hole. Next I'm going to use this little countersink bit, and if you don't bear down real hard with it. It just also works as a real nice deburring tool and just clean up all these holes. And so let's just simply put it in the hole, about that much. That takes care of any little burr that was turned up. The back side will have a lot more burr on it where we broke through. Do the exact same thing here. The last thing I'm going to do is I still got a burr or two, and I didn't want to get carried away on the countersinking, and so I can just take my chisel, scrape it'll break all those little burrs off. Real nice. If I had a piece of mild steel, I might have used the disc grinder, but this is galvanized steel, and so I don't want to use a grinder on it or a file or anything, because I'd take too much of the zinc off the surface. It keeps it from rusting. Next thing we're going to do is we're ready to stick the rivet in, and so I'm going to just stick a couple of rivets through the two center holes, and then so I don't have to chase them around when I turn the shovel over. A little piece of duct tape. To hold them in place so they don't fall out. Now, turn my shovel over, line up both R's, and I'm ready to slide those two rivets in. Now, what I'd like to do is I want to tap those very easily, but not completely set them, just so that they stay in place, and then we'll go along and stick the other rivets in place. So I'm going to use my little 8-ounce ball peen hammer. I think I'll use a center punch to spread the rivet head a little bit more. Now we shouldn't have to worry about it falling out when I tip it back over and start poking other rivets in. So I'm going to poke a couple more. Okay, those three are in. I'm going to put some duct tape on them. Keep them from falling out. And flip my shovel over. And again, set them a little bit more. And finally, we've got then the last three left to align. I wanted to zoom in on this last hole and just show that I think hopefully you can see that the alignment between the aluminum shovel and the new piece of steel, or the hole that we drill in the new piece of steel, is not just perfect. And that's fairly typical because the aluminum is not real flat, and it flexes, and the steel also vents back and forth a little bit. And so if we've got a row of holes, it's not too unusual to have a little bit of misalignment. And so what we do is we use an alignment punch like that. That's a real long taper, and we put it in the hole, work it around, and get it pulled back into alignment. So it makes it very easy to align, even though we weren't perfect when we started. The technique that we'll use here is we'll get our taper punch, we'll force it in the hole as far as we can, work it around until we've got both pieces of metal aligned with each other, and then take our vice grip, clamp it into place so that it'll stay put when I slide the punch out. And now all I need to do is slide the rivet in, and the rivet's in. Finally, I want to zoom in on one of these hollow rivets so you can see the detail on how to finish it. First, make sure the head is all the way down. That's tapping a little bit. Make sure it's all the way down. Now I want to hold my hand on it, use the center punch to swell it out. It's probably about 50% larger than its original diameter. And then finally, hit it 3 or 4 times, and that's done. We can turn and watch one more. And so again, make sure the rivet's all the way seated. Swell it up a little bit. Strike it a couple of times, and that rivet's done. And that's all there is to putting in a hollow rivet. Last, I finished knocking in all the rivets, and you can zoom in and see how they look after I finish them. And then we can back up and look at the finished job. And here we've got the finished wear strip, and you can see that we've got maybe 3/8 of an inch sticking up above aluminum now, and I'm good for another couple of seasons on this particular shovel. The other detail you may have noticed in this video is that my gloves changed and I had to put on a jacket. It's currently about 3 below right now, and my garage is not all that warm, and I could nearly see my breath a time or two shooting this video. It's just plain cold in the garage tonight.